This question probes your understanding of dipole moments and expects you to be able to look at a two-dimensional representation of a molecule and imagine it as a three-dimensional object. It asks you to determine whether each molecule is polar or nonpolar, and to show the direction of the overall dipole moment. Arrows indicating dipole moments point toward the area of highest electron density, and since they tell us that the central atom in each case is the least electronegative, the dipole arrows will all be pointing away from the center. So what's the plan? Well, dipole moments are vector quantities, so the best approach is to add individual bond dipoles together. If they cancel, the molecule is nonpolar. If not, the molecule is polar. And the sum of the vectors will give us the direction of the arrow. We'll have to do some 3D thinking. Now to solve. Starting at the top right, we can draw dipole moments for each of the three bonds of the trigonoplanar molecule. If it's not obvious to you that these cancel to give an overall dipole moment of 0, redraw it or make a model and convince yourself that it's true. If you plot the three dipole vectors, you'll find they form an equilateral triangle, returning to the origin. Hence, you're back where you started. An overall dipole moment of 0 means a nonpolar molecule. The next molecule is trigonopyramidal, so the three individual dipoles look similar to the previous example. However, they all point slightly down, so the overall dipole also points down. A net dipole moment means that the molecule is polar. The next molecule is T-shaped, and the first two dipoles cancel each other perfectly, leaving the third dipole moment to equal the overall dipole moment. Again, this is a polar molecule. The fourth molecule at the bottom left is square planar, and it's comparatively easy to see how the four dipoles neatly cancel each other out to leave an overall dipole of 0, giving a nonpolar molecule. The next molecule is shaped like a seesaw. The dipole moments of the axial atoms cancel perfectly, but the dipoles of equatorial atoms combine to point straight down, giving us a polar molecule. Finally, the tetrahedron. The four dipole moments again cancel perfectly, giving us a net dipole moment of 0 and a nonpolar molecule. Now check your answers. Highly symmetrical molecules tend to be nonpolar, and if you look at the three examples here, that is certainly true. We've also drawn arrows for each of the polar examples, so we're done.